Hi, this is Steve with OSNEXUS, and in this video I'm going to be going over some of the techniques and process that we go through to design new scale-out storage solutions. We've developed some design tools to make this process a lot easier, and we've been improving them over the years. We've got some more enhancements coming to these that'll let you see the estimated performance of your designs. But today I'm going to focus in on our design tool for doing Ceph deployments, the scale out, file block, and object. And our design tools are all publicly available right on our website. If you go to support and then choose design tools and click that link, that will take you to this page that we're on here. And there's two different design tools, one for our scale up style clusters and one for the scale out. It's the exact same software. QuantaStor does both scale out and scale up storage clusters within the same software. In fact, you could have both a scale up and scale out running on the same system at the same time. But today we're going to really focus in on the scale out. So if you go to the one at the bottom and click the button, it will load up the design utility. So I'm going to just make the window a little bit larger so we have a little bit more room to work with here. And we're going to just start kind of going from top to bottom. What this utility is really all about is helping you scope out how much hardware do you need to get a solution together for a certain capacity and a certain use case. So we'll go through a couple of examples here and then try adjusting some of the settings and then go over in some of the storage configuration options that are available. So let's run through an example where you're designing a system for archive. Maybe you need a petabyte of storage for doing Veeam backups. What you would do is you would go here and start by inputting the amount of usable capacity that you need. So let's say that you need, as an example, 1 petabyte. We can go and input that, and that's our starting point. The next is to choose a use case. This part is optional. You can go use all the rest of the utility without specifying a use case, but the use case is kind of handy because it will go and automatically select some of the other options for you. You can change everything around however you like after choosing the use case, but it is kind of helpful, especially if you don't have as much experience designing solutions, storage solutions in the past. This is a great way to start. And if I choose like desktop and server virtualization, that's going to go and set it up with a replica-based layout versus a scale-out archive is going to choose a configuration that is going to use erasure coding. So we're just going to, we can pick like large-scale archive. It's going to have adjusted the erasure coding level for us. But now we're really going to just go in and just start adjusting each of these settings so you can see how to go use the utility and kind of adjust things at a more granular level. So the first thing we're going to dive into is this whole section here on the server cluster specification. QuantaStor works with all the major server vendors and storage vendors to get their hardware certified for use with QuantaStor. And so you can see here we have a bunch of different choices. All of these systems are on our hardware compatibility list, and we're adding more and more systems to this list all the time. So one of our favorite go-tos is this Western Digital Serve 60+8. We can choose that, and then it automatically changes the design to have that, or we could choose a 2U12 bay like this R740. For something that's in the neighborhood of just a petabyte of storage, using some 2U12 bay servers is a perfectly fine way to go. The next is choosing the size of the drive. You might notice here that it's choosing 11 servers. That's because we choose as a minimum number of servers equal to the amount of the stripe length of the erasure coding. So I'm going to actually change the erasure coding to 2+1 so that the minimum number of servers is 3. And then as we kind of adjust capacity and stuff like that, you'll see it take and adjust that count a little bit more for us. So in a 2+1 erasure coding, we would need 9 servers with 14 terabyte drives. Nowadays, there's some larger hard drives. We need to update this version of the utility to have some other drive sizes. But if you adjust the drive size to something smaller, like 10 terabyte, you can see it increased the server count. So that's the really nice thing about the utility. You just set the usable capacity once, and it will figure out how much raw storage you need based off of all of the other settings to meet that goal. So obviously, if we go back to like 12 terabyte hard drives, we need less servers, and if we go up to 14s, we need even less servers. So that's a really handy thing. Using some other erasure coding levels, like 3+1, we'll need even fewer servers. So you can adjust from a selection of all of these various common erasure coding levels. But with QuantaStor, the Ceph-based technology that we use underneath, you can use any combination of data and parity or data encoding blocks. We just put in the most common ones here, so don't feel that you're limited to just the ones that are available in the design tool. So with that, we've gone through the server selection, and we picked a hard drive. The next is this journal and metadata. QuantaStor requires that you have at least 2 journal slash metadata devices on each server if you're using it with Platter. If you're using it with SSDs, then you don't need any journal and metadata drives. They can still help out. If you're using like SATA SSDs, it can be really helpful to still have some Optane in there, Intel Optane drives as your journal and metadata. But we do require, if you are using Platter, that you need to have at least 2 of these drives per server. The general guideline is that you want 30 gigabytes, actually 32 gigabytes of capacity for each hard drive. So in this case, there is room for 12 drives, and 12 times 32 gives us a number of 320 plus 64, or 384 gigabytes. So we probably want to go with a drive that's just slightly bigger. Go with like the 750 gigabytes PCI, the Optanes in this case, or you could choose, another option like just a standard NVMe drive like the 1.62. But anyways, 32 gigs times the number of drives per server gives you kind of the minimum amount for the drive capacity for the journal metadata. So now we've got our drives selected, we've got some SSDs selected to accelerate the performance of both writes with journal and metadata with read-write activity. Now we can kind of like make some more adjustments here. One of the key things to adjust is this data compression. A lot of data out there isn't compressible. Images and video, a lot of this is already pre-compressed. And sometimes if you're using a backup product, oftentimes it's already compressing the data before it goes on to the media. And so if your data is not compressible, just set that to 0. And obviously, when it's not compressible, it's going to automatically adjust the amount of raw capacity again. Right here it said now we need 512 terabytes with compression. You can see that it can adjust the amount of raw capacity that's needed. If it's super compressible, I'm sorry, I was moving the wrong slider. If the data is really compressible, you might need less and less and less hardware. So again, it's doing all that math for us. This reserved free space, that's really handy to adjust if you want to partially populate the servers. Let's say that you wanted room to grow just by adding more hard drives. Then you could say, well, I want to reserve, I don't want to fully populate all the servers. Like right now, this is estimating that we're going to fill all 12 bays in each server. Maybe we want to only fill 8 of those. So if we're going to fill 8, then we increase this to like 33%. And now you can see it's or 9 rather, it's now 75% full. So we're only putting 9 drives per server, and you can see it increased our server count. So that's a real handy way to reserve that space. I'm sorry, I kind of mixed this up. The drive slots is what reserves the drive slots at 33%. The reserved free space is actually for something else. This is to account for how much free space overhead are you going to account for in the design. With all of these scale out designs, and really for even scale up designs, you technically want to have somewhere around 10% of the space being unused because when file systems, pretty much all file systems on all platforms, they start to get less efficient after a particular threshold. ZFS can oftentimes the general rule with that file system is around 70% full. You're going to start to see performance degradation. And with Ceph, similarly, it's a good idea to have room with these scale-out configurations so that if you lose a server, if a server completely fails, it can heal itself automatically and rebalance across the remaining servers. So if you had 10 servers and one of the servers was lost with all of its media, you would need 10% of free space left over for that to fill and get back to 100% health. So that's one of the great features of a Ceph-based architecture is that it can auto-heal, but you do have to make sure that you have free space left over for that auto-heal to work. So that's what this free space is about. And if you have 12 servers, a good idea is to kind of like set it to 10%. If you have like 8 servers or fewer servers, note that it can get back to 100% health even if you have fewer servers than the number of the stripe length, as long as it's has 2 or 3 coding blocks. But it's just a general guideline. Good to have some free space for the auto healing. And if you need it to be able to sustain and be able to handle more server failures simultaneously, then you would just want to increase that reserved amount. So that's what that's about. Again, drive slots, this is more about designing for the future, having room to just add additional drives. And again, free space is about having the free space available for auto healing. So how much of the hard drive space is just not going to be used for data. Sometimes we get asked, should I leave empty drive slots and then add more drives to the existing servers, or should I just add a new server on? It kind of depends. When you have more servers, you're going to get more performance. So if you need to be at a particular performance level up front, then I would recommend having the additional servers and have them partially populated. If you're really just going after capacity, then I would just say, don't worry about the server count and reserving space. I would just set this to this drive slot count to 0 and fully populate all the servers. And then when you need more capacity, just add another fully populated server to the cluster. You can add additional fully populated servers at any time. And one of the great things about the Ceph architecture is that you don't even need to add them. Technically, you could go and add a half populated server to this existing configuration. And the way that the placement groups and the crush map system works is it can now evenly distribute and use just what new drives are available to it. So it's really a fantastic architecture, how it can really work with asymmetrical configurations. Our general recommendation, though, if you are adding 12-bay servers, keep adding more 12-bay servers. You don't want a big asymmetry of having a bunch of 12-bay servers and then a big 60-bay, because that can create all kinds of performance challenges and other things. With the crush map being unbalanced can create other headaches for you. So try to keep the servers the same size. You can use different brands of servers. So say you started with Intel and then later you wanted to add Dell or HP or Supermicro servers, you can mix and match and all that. But try to keep them generally of the same horsepower in terms of compute power and RAM and all those things, so that you get a nice consistent performance out of the system. So that covers the data compression, free space. Again, that's the amount you want to reserve. Generally keep that at 10% or more. On a really big cluster, you could reduce that down to maybe 5% if you had like 20 nodes. And then reserve drive slots, again, if you're planning to intentionally increase the server count so that you've got some empty drive slots, you can just increase this to account for that. That's it. That's all there really is to the design tool. Over here on the right is the spec that we get. So here we decided on an erasure coding of 3+1. if you started discussing it, with your team, and you said, oh, we want double parity, let's go with 4+2. You just put that in there and it'll adjust it. And the whole design is right here in the URL. So you can just take the URL and send it to your friend, send it to your reseller, and say, this is what I'm thinking. And it's all right there. That link is the only thing that you need to send them. They'll just click on that and it will load all the settings right into the app right on there. So there's nothing fancy that you need to do to go share these designs with other people. The whole spec that the value-added reseller needs on the design is right in here, and the number of hard drives, the number of SSDs is all over here. So it makes it real easy to go from the design concept using the tool right into a bill of materials and a price estimate on the hardware. OSNEXUS doesn't sell any hardware. That's why we're a 100% channel-driven company. But once you get some pricing back from your reseller, from your OSNEXUS reseller, they can give you some detail on what the cost of the servers are. Let's say they give you a price for the server and a price for the hard drives and a price for the SSDs. You can then input those back into the utility and start to get some estimates on what it costs in terms of a price per terabyte per month. So we do a little bit of math here on the pricing in terms of how cost efficient you are with the hardware once you put some numbers in. So again, you need to get these from your reseller. The hardware, we don't sell any hardware. You've got to get that from your OSNEXUS reseller. But you can see here as you add more and more capacity, you can see it adjust what it works out to in terms of the price for the hardware and software, the MSRP on the software. And then here you get a number as to what does this work out to in terms of price per gigabyte per month. So on a configuration like this, based off of a 3-year gold support, 24/7 support license, it works out to 0.005 cents per gigabyte per month, or rather $0.005 per gigabyte per month. So it's less than it's 1/4 of a penny per gigabyte per month, much more. So it just goes to show how cost efficient private clouds are versus doing storing the same data in the public cloud. I hope you enjoyed the video. If you have any questions, write us at info@osnexus.com, and look forward to hearing from you.